Good morning. Oy, good afternoon. I will be discussing this afternoon one way how to connect uh, solar energy connections. One of the connections that is being used under solar energy is the off-grid solar energy connection. Off-grid. Off-grid meaning it is not connected to the grid line. It's just standalone. Okay, so it just involves solar panels, solar charge controller, inverter. That's it. Okay, I will try to bring out the block diagram and how to connect off-grid solar energy connection. Okay. Off-grid solar connection. Off-grid meaning it is not connected to the utility line. So it needs a battery. It needs a battery. You must have to charge your battery to power up your inverter, okay, so that it will produce alternating current. So the main components for off-grid connection, I will bring you up. You got solar panels, you got the solar charge controller, and you got an inverter. Or the proper connection will be something like this. To increase the charging current, the connection of the solar panel should be parallel, meaning all the plus terminals of the solar panels are bundled into one, okay, and it is connected to the plus terminal of the solar charge controller. All the negative terminals, okay, are bundled into one or interconnected into one, okay, then it is connected to the negative terminal of the solar charge controller. What's the significance of this? The significance of this is that the total charging current will be the current coming from solar number 1, solar panel number 1, solar panel number 2, and solar panel number 3. The significance of this is that if you got more solar panels, you got more charging current. Okay? And if you got more charging current, you could actually charge your battery faster. So if you need battery ASAP, okay, your inverter will be on and you could bring out alternating current ASAP also. Okay, I will give you the connection. The connection for the meantime, I will just give you only 3 solar panels. Solar panel number 1, solar panel number 2, solar panel number 3. The solar panel is in here. I got a solar panel here. And it got 2 terminals. The positive and negative. This is the actual connection. Actual connection, actual connection. So imagine for the meantime that we get 3 solar panels in which the 2 terminals are interconnected. I repeat it. To give you more charging current, all the plus will be bundled into one and it's connected to the plus terminal of the solar charge controller. And all negative terminal, okay, are bundled into one and connected to the negative terminal of the solar charge controller. And what's the significance? Solar panel number 1 will give charging current I1. Solar panel number 2 will give charging current I2. Solar panel number 3 will give charging current I3. Okay? it will go in here. So in here, IT, meaning the charging current, the total charging current. The total charging current is actually IT equal to I1 plus I2 plus I3. This is for parallel connection. Okay? The more you got solar panels, the more charging current you can have. Okay? So if you got lots of money, buy lots of solar panels, then connect them in parallel to give you more charging current, so you could expedite the charging of your oh, I think I missed something over here. Sorry for this one. I will just rectify this one. I missed the battery. Okay. There should be a battery over here. Okay. This is the plus terminal of the battery, and this is the negative terminal. So the plus of the solar charger will go to the battery plus, and the negative will go to the minus. Okay. Then there's an output for the battery. This is the battery, guys. I almost missed this one. This is the plus terminal of the battery. This is the negative terminal. On the inverter, there is the plus and minus terminal. This is the plus and the minus. Sorry for this one. I almost missed the battery, di ba? The plus will be connected to plus, and the minus will be connected to minus. This battery. So I missed one. Okay. Solar panels, solar charge controller, it goes to the battery. Then from the battery, it goes to the inverter. Then that will be the time you will have an alternating current 120 volts here in the USA. I will repeat it. The total charging current is I1 plus I2 plus I3. This is for parallel connection. So if you've got 4, this should be plus I4. If you got 5 solar panels, this should be up to I5. Okay? But in general, for parallel connection, the total charging current will be I1 plus I2 plus I3. Okay? Or this should be I total in general will be equal to the summation of the individual currents. This is an engineering notation, summation. Total charging current will be the summation of the individual current coming from the solar panels. So for this example, I got 3, so this should be I1 plus I2 plus I3. If I got 4, it should be I1 plus I2 plus I3 plus I4. If I've got 5 solar panels, it should be I1, I2, I3, I4 till I5. Or in general, the total charging current will be the summation of the individual current coming from the solar panels. So it depends on how many solar panels you will connect in parallel. Okay? Panel number 1, panel number 2, panel number 3. Oh, I will give you an example. Supposing I1 is 5 amperes, I2 is also 5 amperes, and I3 is also 5 amperes. Okay? We connect all the plus terminals, so it will go to the plus of the solar charger. So the total current here will be equal to 5 plus 5 plus 5 equal to 15 amperes. So the total charging current that will go into the solar charge controller will be 15 amperes. And that will be the current it will give to the battery. Okay? It's 15 amperes. Supposing it is 4 panels, so you add plus 5 more, so it will be 20. So I said a while ago, the more current you have, you could expedite the charging of your battery. But the use of the solar charge controller is that if this battery is already fully charged, okay, I think this solar charge controller will limit the current going to the battery, so it will not be damaged. But as long as you are using your load and you are charging the battery, I think you will not overcharge your battery. Okay, that's how an off-grid solar connection works. The connection should be parallel for you to have maximum current, maximum charging current. We are not talking series connection here. Series connection is another thing, you know. But for off-grid solar connection, to maximize the charging current, the connection should be parallel. All the plus terminals bundled into one, connected to the plus terminal of the solar charge controller. All the negative terminals bundled into one, connected to the negative terminal of the solar charge controller. Then later on this solar charge controller, I will erase this one. There will be an indicator here, how much is the voltage and how much is the current. Okay, so it could be maybe 13 volts, or this should be 15 amperes, something like that. It is something like this. It got an LCD thing, so while the sun shines, it gives current, so it will bring out a voltage here and a current here. So you will know that actually your solar connection is have a good connection, meaning it's working. So you know if the sun actually try to energize the solar panels to give current and to pass it through the solar charger. It is something like this. Okay, this is a solar charge controller. It got the terminal coming from the solar panels. It got a terminal going to the battery. The other two terminals are actually, you can actually insert load now here. Any load that needs direct current here. Okay? But the main thing here is that the first two terminals is coming from the solar panels, and the next two terminals is going to the battery, and the plus and minus of the battery goes to the plus and minus of the inverter. I will discuss what is an inverter. Inverter is a machine that converts direct current to alternating current. This is direct current. Then it will convert, this is I, this is time, this is I, this is time. It will convert to something like this. This is an alternating current. Alternating current because the current we use in our homes are alternating current. Some are alternating current, but to use a direct current, you got your DC gadgets, you know. You plug into the AC outlet, like the charge controller, like the cell phone charger, okay, you can bring out a DC voltage, okay. So inverter is a machine that converts direct current to alternating current. Direct current, straight line, it will change to alternating current. And actually, you could check the frequency of the output here. And the USA, the frequency is 60 Hertz. That's it, guys. That's the proper connection for an off-grid solar connection. And the proper connection should be parallel connection to maximize the charging current and to expedite the charging of the battery. Because if you are using your AC voltage here, you need your battery to be fully charged for this to work correctly. Okay? Because if the battery voltage is low, this will not work. It will shut off. Okay? So you must have to maintain the battery voltage here. But as long as the sun is bright, okay, the charging current will be more than enough to charge this battery for the whole day. Not the whole day, maybe an average of 6 hours. It depends on your location here in the USA or in the world. Okay? So you got to have a steady battery voltage for the inverter to work. Okay guys, good afternoon.